Hello everyone, welcome to my channel and welcome to another video on integration. And our first integral is the integral of dx all over 1 plus square root of x. So let's go straight into it. Going to page 1, we have the integral of dx all over 1 plus square root of x. I'm going to rewrite this integral as follows. This will be equal to the integral of 1 all over 1 plus square root of x dx, like so. At this stage, I'm going to introduce what I call the special one. I multiply the numerator by square root of x and also in the denominator as follows. This is the same as the integral of square root of x all over 1 plus square root of x, and I'm going to put this in brackets and I'm going to say times dx all over square root of x. Notice that these two can cancel. I'm back to that original integral there. But at this stage, I'm going to let u be equal to 1 plus square root of x, this part here. Now, I must solve for square root of x first here. So this equation implies u minus 1 is equal to square root of x. The first part. The second part would be to differentiate both sides. But for me to differentiate both sides, I'm going to have to rewrite the right-hand side. So this is u is equal to 1 plus x to the power half. Remember, square root of x is x to the power half. Now I can perform differentiation of u with respect to x. Du is equal to, using power rule, du dx is equal to, remember derivative of 1 is a constant, but derivative of x to the power half is 1 over 2 x to the power half minus 1. Remember power rule? Now, let's simplify the right-hand side. So du dx on the left. On the left, we have du dx. So I'm basically saying du dx on the left. On the right, we have 1 over 2 x to the power minus 1 over 2. Multiply both sides by 2. You're going to have 2 du dx is equal to x to the power minus half. Rewriting this one here, we have on the left 2 du dx. On the right, we have 1 over x power half. And rewriting the right-hand side again, we have 2 on the left du dx. On the right, we have 1 over square root of x. Power half, remember, means square root of x. X to the power half means square root of x. Multiply by dx both sides. You're going to get du, 2 du is equal to, basically, dx all over square root of x. This is exactly what we wanted to achieve over here. Remember, this part here is what we have there. So in place of that, I'm going to have 2 du. And then in the numerator, I'm going to have 1 minus u. You can see from here. In the denominator, I'll just have my u there in the denominator. So our integral changes to, if I squeeze it in, I'm going to say that integral will be equal to the integral of u minus 1 in the numerator all over u, and then multiply by 2 du. If you notice here, that place there must be replaced by, I'm talking about square root of x is actually equal to 1 minus u. That part there will be u, as you can see. And then this expression here should be replaced by 2 du, like this. Now, so I'm going to take 2 out because 2 is a constant. I'm going to take 2 out because 2 is a constant. And then I'm going to continue with integration as follows. So 2 is a constant. Let's take it out. So that will be equal to 2. And we're saying, allow me to use brackets here, the integral of u minus 1 all over u. And we're saying du, like that. Now, I'm going to perform term-wise division inside there as follows. 2 and I'm going to say the integral of u over u minus 1 over u, like that, and we're saying du. Now distribute du and then the integral there. You're going to have 2, the integral of, notice this is 1, and then we have du, and then we're saying minus the integral of 1 over u du, like that. Now evaluating the two integrals, you'll agree with me that this is 2, integral of 1 with respect to u is u, minus integral of 1 over u is just natural log of u, like that. And then we have to say plus c because we're done with integration. Let's distribute the 2. So we have 2u minus 2 natural log of u plus that, our c constant. But remember, our original variable is not u, our original variable is x. Where is the connection between the two? And here is the connection on our page 1. We're saying basically u equals 1 plus square root of x. So where I see u, I must put 1 plus square root of x. So this is going to be 2, 1 plus square root of x minus 2 natural log of, notice that now I don't need absolute values, 1 plus square root of x, and that's a positive square root, plus c. This will never be negative, remember. Now this would be the final stage, but I want to show you that this can simplify a little longer or further. Multiply or distribute the 2, so that's 2 plus 2 square root of x minus 2 natural log of 1 plus square root of x plus c. Now what I'm saying now is, notice the 2 and the c are constants, so I can just combine them into c1, for example. So this would be something like 2 square root of x minus 2 natural log of 1 plus square root of x, and then plus something like c1 or c star or asterisk. So this would be the final solution. Like I said, stopping here would just be fine. Stopping at this stage would still be okay there, but you know, this would also be just as fine. Right, so this is the end of our first integral. Remember the special one coming in very prominently here, over here. Otherwise, without that, it would be extremely difficult. You would have to use what we call conjugates to be able to evaluate this. By conjugates, I mean the conjugate of 1 plus square root of x would be 1 minus square root of x. You'd have to multiply in the denominator and in the numerator and then proceed from there. Right, let's look at the second integral. The second integral we have is this one here. This is our second integral. How do we go about it? Well, again, applying the same technique we've used in our first integral, we can rewrite this and proceed as follows. The second integral is the integral of dx all over square root of 1 plus square root of x. Rewriting this like we did in the first one, 1 over square root of 1 plus square root of x multiplied by dx. Introducing the special one, the integral of square root of x all over square root of 1 plus square root of x times dx all over square root of x. There is your special one there. This cancels that. You're back to the original integral there. But at this stage, we're going to say, because of the square root sign now, we're going to say let u squared be equal to 1 plus square root of x. And then do the same things we've done in the first one. The first one would be to solve for square root of x here. So it would be u squared minus 1. That would be square root of x. That's the first part. The second part would be to rewrite this and then differentiate. We're going to rewrite the right hand side. So u squared is equal to 1 plus x to the power half. Do implicit differentiation of u squared with respect to x. You'll agree with me that this is 2u du dx. We differentiate the function. First, 2u multiply by 2, reduce the power by 1, and then differentiate u with respect to x like this. Implicit differentiation. This is going to be equal to derivative of 1 is 0. It's a constant derivative of that. Like we've done in example number 1, this is going to be half x to the power minus half. Rewriting this equation here, we get the following expression. What we get is basically 2u du, and I'm going to say dx is equal to 1 over 2 times 1 over x power half. Multiply by 2 both sides. We're going to get 4u du dx. On the right hand side, you have 1 all over square root of x. Remember, that's the meaning of square root x power half. Multiply by dx both sides. You're going to get 4u du is equal to dx basically all over square root of x. And this expression here is exactly that expression there. So now in the denominator we have u squared there. In the numerator we have u squared minus 1, and then we proceed from there. So that integral then is transformed as follows. We can say is equal to which integral? This one here. Remember, in the numerator I'm going to say u squared minus 1. So integral of u squared minus 1 in the numerator. Let me put in brackets because that's square root of x. From here you can see the square root of x is actually u squared minus 1. In the denominator I'm going to have square root of u squared, right? All over square root of u squared. And then I'm going to say, what is this last part here? The last part is actually equal to 4u du. 4u du. Like that. Fantastic. Now, let's clean up. So this is the same as the integral of u squared minus 1 all over u. Remember, that cancels that. Times 4u du. This u cancels that u. And we have the integral of, let me take 4 out because 4 is a constant. U squared minus 1 in brackets du. That's what we have. Now, how do we go about this? Well, we proceed as follows. Distribute the integral and the du, taking us to the next page, which is our page 6. What we have now is the following. Let me move this one down. Right, so what we have now is 4. Let me keep 4 outside. The integral of u squared du minus the integral of 1 du. Like that. Let's evaluate the two integrals. We have 4 outside, and then we have u power 3 over 3. Remember, you add 1 and divide the exact. Minus integral of 1 with respect to u is u, and then I have to say plus c, because this is an indefinite integral. Now, distributing the 4, we have 4 over 3, u power 3 minus 4u plus c. Let's go back to our original variable. Our original variable is x. What's the relationship between u and x? From here you can see that you would need to take square root on both sides to determine the value of u. So this means u is equal to square root of 1 plus square root of x. That is u. From there you can see we take square root both sides, and this is what we get. So I'm now saying this is the same as 4 over 3. In the place of u, I'm going to say square root of 1 plus square root of x. As you can see over here, 1 plus square root of x, square root of 1 plus square root of x, that's the value of u. You can see it there, right? Yes. Let me put this one in the right place there, so you can see that expression there. Now, so basically I'm saying this is what we have, but this has to be to the power 3 minus 4, and then we're going to say square root of 1 plus square root of x, and then plus c. Let's rewrite this part here. If we are to respect the format in which the question has been presented, we're going to say this is the same as 4 over 3, and remember laws of exponents. This will be square root of 1 plus square root of x, all cubed, and then minus 4 square root of 1 plus square root of x plus c. Otherwise, this part here, you can also write it as, let me just give you another form here. Another form would be 4 over 3, and then we are saying 1 plus square root of x all to the power 3 over 2. Remember, taking square root of 3 over 2, and then we are saying minus 4. You can also write the same way, that like that, power half, and then plus c. Both forms are just as fine. So yeah, so whichever form you like. I like this form here because it respects the format in which the question has been presented. We have the square root sign in the original integral, and therefore our solution maybe would need to have that here, square root of 1 plus square root of x. You would want that to appear in your final solution like this here, but this is just as fine. All right, this is where I'm going to stop in this video. Many more videos on integration will be coming your way. If you're new to the channel, please don't forget to subscribe and support us by sharing these videos, providing us with feedback. We value your feedback. All right, I'll see you in the next one.